Right, so in this question, number 14, this is tricky because we don't know the percentage, and we're trying to find the percentage. What is that x? So we don't know the rate at which it decreases. There's a few other things that makes this one tricky as well, but the idea is we have a number of fish in the lake, and if it decreases by the same amount 8 times, you've now got half the number of fish that you started with, and we've got to figure out, well, what was it going down by each time? So let's have a go at doing this question. It turns out that it doesn't matter how many fish you start with. So that might be a bit surprising. Remember, in general, we've got this, and we've got P times MNQ, where in this case, this would be the number of fish you start with, which we don't know. This would be the multiplier you use to do the percentage reduction, which we don't know. This would be the number of times it decreases. We do know that. That's 8 in this question. And we don't know Q. Q here being the number of fish you end up with. We don't know that either. And to make the question slightly easier, why not just make up a number of fish that start in the lake? It does not matter. So let's make a number up. What's your favorite number today? Let's say that the lake starts with 1,000 fish. So let's say that P is 1,000. It turns out you can do any number you like for P. I'll try to explain that more as we go on. But for the moment, I'm just picking a random number for P. This is how many fish we start with. Now, I don't know the multiplier because I don't know the rate of interest. But I do know that I'm going to use this multiplier to decrease 8 times. So power is 8. And I do know that I end up, after 8 decreases, with half the fish that I started with. Well, if I started with 1,000, then I'm going to end up with 500 fish. Okay, so that's the situation that we've got here. I don't know the multiplier, but I do know that I use it 8 times, so I decrease 8 times, and we go from 1,000 down to 500. Now to get m on its own, notice how at the moment m has been powered up by 8 and also multiplied by 1,000. So let's divide both sides by 1,000. Left-hand side divided by 1,000 is just this. Right-hand side divided by 1,000, that's 0.5. And maybe you can see now at this stage, it didn't matter what number we chose to begin with, because if I'd said over here that there were 1,000,000 fish in the lake to start with, over here I'd have 500,000, and then 500,000 divided by 1,000,000 is still 0.5. So it did not matter at all what you could have said I started with 20 fish, and then you put 10 over here, but 10 divided by 20 is also 0.5. So that was a bit confusing, but it turns out it didn't matter how many fish you start with, because by the time you've done the division, you end up with just 0.5 no matter what you started with. Right, now how do we undo a power 8? No, it's like a type of rooting. You know that if you undo squaring, you need to use square rooting. You might have seen undo cubing with cube rooting. This is the same idea. To undo a power 8, you need to do 8th rooting. And it's written like that. That's how you write 8th root. Now, it's on my calculator. Now, where is it on my calculator? Now, it turns out that the 8th root is, I'm just off the screen, I think. Let's go back on. There we go. Turns out that to get 8th root, it's above this button here, above the any power button. Okay, so the buttons in order go square root, squaring, any power, but above any power is any root. So that's the one I want. It's in yellow, but it hasn't come up very well on the video, but it's above the any power button. So I'm going to press shift and the any power button, so it comes up with any root, and you can see how it's displayed on the screen. Hopefully it's got this little thing here. So I'm going to put an 8 in there, and in the house I'll put the 0.5, and it comes out as this: 0.917 blah blah blah. Okay, I won't round that yet. I'll keep it for the time being. This is the multiplier then that we used to do our decrease. This is a decimal. To turn a decimal into a percentage, that's just times by 100. Okay, so all this is nothing more complicated than this is a decimal. If I times it by 100, I get it as a percentage. So let's multiply that by 100. And that's telling me 91.7004 blah, blah, blah. So the meaning of this is every time you did a reduction, you were left with 91.7% of the fish you had before, so fewer fish than you had before. Okay, so it's gone down by about 8 or 9%, hasn't it, roughly? To get from 100% of the fish down to 91.7% of the fish, it's gone down by about 8 or 9%. I can work out exactly how much it's gone down by if I take that number from 100. So if I do 100 minus that answer, leaves me with 8.2995, blah, blah, blah. So it's a reduction of 8.2995, blah, 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 like so. And I think the mark scheme just said that 8.3 was good enough. If you round this to one decimal place, 8.3 was good enough. So what's happened is, just those steps again, we were trying to figure out what the percentage decrease was, okay? Because the question said it reduces by X%, and can you find what X is? So what we did is we said, well, I don't know the multiplier you need to do an X% reduction, so we just called it M. I didn't actually know the number of fish, but it doesn't matter. You can make up a number. But I did know that it happens 8 times. So if I do 8 reductions, I end up halving the number of fish. So it goes from 1,000 to 500 here. But you could have chosen different numbers. By the time you divide by this number on both sides, you'll get 0.5 there, no matter how many fish you started with. To undo power 8, you do 8th root. It gives you that. That's just typing it in. This is the multiplier you use then to do the reduction. So if you times by 100, you can see that every time you reduce, you're left with 91.7% of the fish you had before. That's less than you had before. It's specifically 8.2 blah, 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 less than it was before. Percent less than it was before. And if you round that, that's 8.3 less than it was before. And so I've answered the question because it was saying, by what percentage are we reducing each time? Yeah, X%. And I'm saying, oh, I'm reducing by 8.3% each time. By no means an easy question, but that's how you do it.